All right. Let's see. I think I have 12 people right now. That is very few compared to most days. Maybe another minute or so for people to kind of trickle in. How you doing, Gavin? It's good to see you here. All right, now we're up to 14 people. It's a little better. Like I said, this is going to be the review sheet we're going to go over. And I know we didn't have class yesterday. Our faculty meeting extended a little bit longer than I thought. And it does take me a while to get this kind of set up. So, and I didn't want to change the time. I like to keep you guys on a routine. I will always try to do 11 to 11:40 each day. So if a meeting kind of interrupts that, then so be it. So a few important things that I do want to discuss before I jump into this review sheet is number one, and I know this came up on Tuesday, was the fact that are we going to be doing this through spring break, or what is spring break going to look like? We have been directed that instruction should continue, although the instruction might be a little bit more laid back. We are going to continue doing some things. So I do have a plan, and it's going to be a little bit experimental. So I think the spring break week is actually the best time to experiment with something like what I'm about to announce. Is I want to start the circle unit after it, but it does look like our time teaching, learning remotely is going to be extended. And for that reason, I might start doing some graded assignments like homeworks in the circle unit. Now, how does handing that in look like? How does stuff like that look like? And I'm going to tell you right now, it is going to be far less intensive than actual class. I'm thinking one assignment per week or something like that. I'm still not going to do a weekly every week. Maybe, I don't know, maybe we'll change them into monthlies. I don't know. Or, so, I don't know, something a little different. It's still not going to be as intensive as class. It's not going to be a homework assignment every single night. That's not what I want it to be. But I think it would be valuable for you guys to hand in something. So we're going to test it out this week. And I am going to make a Google Classroom for geometry, and I'm going to post the test to what you would have had for this unit. I'm not grading it. Since this is experimental and whatnot, this is strictly for extra credit. Now, one thing I do want to know is, does anyone or anyone not able to print things from home? And that's one thing I'm curious about. You can just throw it in chat just so I have a general idea if is it like 50-50? Is it just a handful of you? Whatnot. Who can print things from home and who cannot? Because this will kind of indicate how I will do things in the future. So just throw it in chat so I get an idea of who can print, who cannot. And as you're typing that out, I'll continue explaining. So it looks like a lot of you cannot, which is fine. So what I will do is I'm going to post the test on Google Classroom. If you can print it out, great. You can do it that way. But this is going to be the first time we're going to try to hand in an assignment through Google Classroom. And like I said, this assignment is strictly extra credit. You do not need to do it. And as it's kind of experimental, it is going to be a very generous extra credit assignment. Your goal is to just complete the test. I put in quotations test. It's the test we were reviewing for right now. It's the one that we would have taken in class. And I want you to see if you are able to submit it on Google Classroom. If you cannot print, because if you can print it, you could scan it on your phone, make it into a PDF, and go that way. Otherwise, did the stream cut out? I think it froze on my end. But there it goes. Oh, okay. On my screen, it was frozen. I want to see if you can scan it and submit it on Google Classroom. But if you're unable to print, you can't print it out and scan it, obviously. Just throw it in the answers, possibly in a Google Doc or something like that. For multiple choice, that would be easy. For the ones that require math, I think it's going to be a little bit more challenging. So I'm just asking, just put answers in a Google Doc. So you don't need to show work and stuff like that. Again, we're just trying something different. This is what we're going to be trying over spring break. I'm probably not going to stream every single day next week. I'm thinking only 1 or 2 days. I'm going to probably on Monday post the test, maybe guide us. I'm going to make the Google Classroom today so I can get everyone invited to it. And then from there, I'll post the test on Monday. I won't even do a full stream on Monday. I'll just kind of explain it, stuff like that. I'll have you guys do the test. If you can't print it out, just do it on a separate sheet of paper or something like that. See if you can scan it with your phone and submit it to Google Classroom. Again, this is extra credit only. This is my plan for next week. Instead of jumping into the next unit, we're going to spend pretty much all 5 days experimenting with Google Classroom, seeing if we can do assignments this way. Because I know doing math through Google Classroom is very hard. Doing English on Google Classroom is probably a lot easier. Typing essays, sentences, things like that are a lot easier. But would just be taking a picture, be okay, yeah, absolutely. Taking a picture and submitting it that way on Google Classroom would be great. Any way you can find a way to hand it in. Because if I can get the majority of the class have a method of handing something in, we can kind of proceed that way. It also gives me an idea on who can work this way a little bit digitally, because how the plan is the next packet of things won't get mailed out until April 21st. That's a long time, and I want to start the next unit a lot earlier than that, meaning I need to post that unit onto Google Classroom. And some of you, unfortunately, won't be able to print it out, but you'll have the empty notes there, and you'll have to write everything down on separate sheets of paper. So I'm just, that's why I'm using the spring break week as kind of experimenting, because I'm unable to get you the physical materials in your hand. And this way I can see assignments that I could grade in the future. That's why you guys should use this opportunity, not just for extra credit, but learning how to hand in materials in the future. Does that mean we are coming back to the school the 14th? I'm operating under the assumption we probably are not coming back on the 14th. And right now I think it's to the 15th. That is statewide, that we're not coming back until at least the 15th. So I know that is a lot of announcements. It's a lot to take in. Again, I'm going to set up the Google Classroom today, probably in the afternoon after my physics class. I'll get everyone invited just to make sure that everyone's there. Tomorrow, I'll probably give out the same thing again. I'll post the test, make sure everyone can view it. And then next week, you'll have time to actually do the test on your own and find a way to submit it. Friday is probably going to be a day on stream where I go over that material. And that will officially conclude our quadrilateral unit. So that following Monday, we would start circles. Okay? So that's kind of the tentative plan. A little bit different. Next week will be a little bit different than the last 2 weeks, but we'll pick right up again right after spring break would have been. Because we have been told, we are going to continue with a little bit of instruction, but we are going to, lay back a little bit. That way you can still have a little bit of time off, a little bit. All right? If you have any questions with that, just throw it in the stream and I can answer them. Yes, all my streams are on YouTube, and you can view them all through Twitch on the videos tabs right at the top of the screen. If you're viewing it from a PC or a Mac or something. If you're viewing it from a phone, I don't know where it is. But on Twitch, they do get deleted after about a week or 10 days or something like that. So my very first ones wouldn't be there. So take a look at where the YouTube is. I'll try to pull that up right now. That way you can see all the videos and so forth. I'll link it later towards the end. But we're going to get started because we're already 10 minutes in, and that was a lot of announcements. But I do have a YouTube. I think if you just type in my name and like quadrilaterals or parallelograms, so if you type in John Glass parallelograms, they'll pop up. Right now, for some reason, my YouTube is not popping up on my screen. Yep. There's a link to the actual channel. I think that's all the videos right there. All right, let's get started. So this would be the review for the test. In class I would have given you a day to do it. We would have a day to go over it, and then you'd have the test. Tomorrow, my goal is to do that Kahoot again because there are questions on that test that will be just like that, identifying what kind of or the closest classification to a parallelogram you could give something. Which are these questions down here are dedicated to all of those. We're going to spend probably most of the review sheet going over this section right here. And then I think I have two proofs. Maybe at the beginning of the stream tomorrow, I can go over the two proofs because I know they take a lot more time. Whatever we don't finish in this review packet, I'd suggest try out on your own if you'd like, and then I can go over it tomorrow. All right, in the very first one, they don't say that it's a parallelogram, but we're going to operate under the assumption that this is a parallelogram. So the basic algebra ones, which there's not going to be a lot of questions like this on the test, or even the Regents for that matter, because these are considered the easiest type of questions, and as far as how easy this is, you're unlikely to see these that often. They usually don't put questions this easy because in this parallelogram you see that angle K and M are labeled with algebraic expressions, and we're just using the rule that opposite angles are congruent. So we just set them equal to each other. 8x plus 17 equals 12x minus 39. So unfortunately yes, this question is easy, but the unfortunate part is that you're not likely to see something like this on the Regents. Just doing some quick algebra, we're going to add 39 to both sides. We're going to subtract 8x from both sides. And it looks like I get 56 on the left-hand side. And 4x on the other side. That's what do you struggle with? I'm going to divide both sides by 4. And I get x is equal to 56 divided by 4. What is that? 1, is it 16? $14. Is it? It is 14. All right. Before I actually circle the answer, I'm going to go back to the question because I actually don't even know. They said find angle n, which is great because that makes 14 not the final answer. It also says this is the angle we're looking for, which is not even labeled as one of the x's. So that means that we can only plug in for the things that we have, either angle K or angle M. So we're actually using the second rule as well as adjacent angles are supplementary. So we're going to find one of the angles because these two angles are going to be supplementary. These two kind of clumped right here. I'll plug in the top one because that one looks maybe a little bit easier. So I'm going to do 8 times x, which was 14, plus 17. I'm just going to throw that into a calculator so we can get what that angle is. So 8 times 14 plus 17, 129. So that's 129, making the angle at the bottom, the acute one, angle N, the one we're looking for, the supplement of that, which is 51. Well, yeah, I mean, they're basically like take-home tests. But remember, this test, again, quotes, is just extra credit. Anyone who does it and is able to submit it on Google Classroom will get extra credit regardless of how well they do. I'll still grade it for you so I can give you an actual grade for it. But just note that grade is, in a way, irrelevant. If you've done the work and handed it in, you'll get the extra credit. Because we're just kind of testing it out, and that's why I want everyone to try it. So angle N is 51. And that's our answer to the very first one. Angle N is 51 degrees. All right, let's take a look at the next one. So the next one, it's obviously not a parallelogram, but because they show that these two lines are parallel, we do have a trapezoid. Even if you did not know anything about trapezoids, you do know things about parallel lines. And consecutive interior angles are supplementary. So therefore, these two angles right here are just going to add up to 180 degrees. So 8x minus 2 plus 5x plus 26 is equal to 180 degrees. We're going to combine like terms. Which one did I have you do on your own on Tuesday? Was it a proof? Oh, yeah, the proof. Yes, we will. How about I go over that one after I do this section right here? But you're right, I forgot about that. So I will make sure I go over that rectangle one. Continuing with this one, combining like terms, we get 13x plus 24 equals 180. Subtract both sides by 24. 13x equals, what is that, 156. And then divide both sides by 13. So 156 divided by 13 is going to be 12. And then plug in for angle h. 8 times 12 minus 2. Angle h is equal to, so 8 times 12 minus 2. You get 94. So pretty straightforward. Like I said, that's the easiest types of questions we could see. Whether there are sides labeled, angles labeled. It's just directly using the properties of parallelograms and tying it in with algebra. Nothing new. We've done this with every single unit, every single geometry theorem we've seen. We've done this kind of stuff. This stuff down here is going to be the stuff that is more challenging. This is just like the Kahoot that we did last week or earlier this week. I think it was last week, where they're going to give you just some pieces of information, and we are going to make the closest classification. That's why it says the best possible classification. So even though if it ends up being a square and you write parallelogram, and you're going to say, well, squares are parallelograms, so isn't that true? It's like, yes, that's true, but it is not the best possible classification. So in general, now they just give you this diagram right here, a basic square. All the answers are not going to be square. They're going to be one of the parallelograms or possibly nothing. We do have to remember this stuff right here. This is by far the most important stuff. This is the basis of the unit. This is, out of anything to kind of memorize, know really well, it's this stuff and how it works. Remember that whatever piece of information they give you, your first goal is to establish, did they give me enough information to establish it's a parallelogram? If they did, you can go on. If they did not satisfy any of these 5 conditions, plus this one to the left, that one also counts, so 6. If they don't satisfy any of those 6 conditions, it's not a parallelogram. So it has to be able to do one of these things: opposite sides parallel, congruent, opposite angles congruent, consecutive angles supplementary, or diagonals bisect each other, or if one pair of sides is congruent and parallel, then it's a parallelogram. If one of those is true, and there's more information that can be analyzed, you then go to these 2. If they give you the proper information, then we can establish it is classified even further. If it satisfies the conditions of all 3, if we have a condition that is true for a parallelogram, a property that's true for a rhombus, and a property that is true for a rectangle, then we will classify it as a square. So if all 3 are true, then it's a square. So, and I think the more you do these, the easier it gets. So the diagram is there, again, as a guidance. It is probably best to use a pencil and erase the markings afterward. So for each example, I'm going to mark it, but because, this is literally, well, how many questions is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 13 different examples for one diagram. So if you're using pen, probably not the best to mark it, because once you get to the 2nd, 3rd, 4th example, your diagram is going to be a mess. We're just trying to figure out what is the best parallelogram we could do with this information. So this says AB is congruent to CD, and AB is parallel to CD. So if we go to our flow chart indicates, well, that's this condition right here. It's the same pair of sides. One pair of sides is congruent and parallel, therefore, this is at least a parallelogram. And that's the only information they gave me. So the only classification I can give this is just that: a parallelogram. So now I'm going to erase these. Now number 2, AB is congruent to CD. And BC is parallel to AD. So in this case, this is not one of the conditions for a parallelogram. Therefore, this is nothing. We can classify this as a specific type of quadrilateral, though. If you wrote not possible or nothing in the blank, I'd probably be fine with that. But the best classification for this one would actually be an isosceles trapezoid, because it's one and only one pairs of sides that are parallel to each other, and it has two legs congruent. So this is actually information that is telling you possibly a trapezoid. It's not enough information to classify it based on any of the parallelograms. So I would say the best possible classification is an isosceles trapezoid. That's usually the one that would, that one usually gets some people. Now the next one says AB, AD, AB is congruent to AD, which is congruent to DC, and is congruent to BC. So, in other words, they're just saying all sides are congruent. Now, if I go to my properties, and these are why sometimes these can get a little tricky. That is jumping right to this step right here. All four sides are congruent. But is that enough? Is there enough information to establish that any of these are true? So it's really easy to say that this is not possible because they jumped right to a rhombus property. But you also have to keep in mind that just by having this property, four sides congruent, if all four sides are congruent, you have, well, if all sides are congruent, the opposite sides are obviously then congruent. And that's a property of a parallelogram. So by giving you just that one, this one actually is, in fact, a rhombus. Because it does satisfy a condition from the parallelogram. Whoops. Because this one right here, this condition is met automatically if all four sides are congruent. So yes, it's a parallelogram, but furthermore, it is a rhombus. There's no information that we could justify a rectangle. All four sides congruent does not tell me that the angles are right angles, and they tell me nothing about the diagonals. Therefore, the closest classification for this one is a rhombus. BD is perpendicular to AC, which tells me diagonals are perpendicular. Diagonals perpendicular is, you should know right off the bat that, oh, I gotta stop putting that one up. Diagonals perpendicular is the property of a rhombus. That is one of the most fundamental properties of the rhombus. But you also have to ask yourself, is that enough information to say any of these are true? Does not tell me that opposite sides are parallel or congruent. What about the other one? Opposite angles congruent? No. Consecutive angle supplementary? No. And it does not say they are perpendicular bisectors. If they were perpendicular bisectors, then it would be great, but they're not. So I don't have any of the information. I don't have this either. So even though it's very easy to jump to the conclusion that this is a rhombus, but because of the fact that this cannot justify a parallelogram, it is not always a rhombus. So this is nothing. Or if instead of nothing you can write quadrilateral, I'll just write NA. You can't classify this like anything, as anything other than a quadrilateral. So hopefully that makes sense, because like I said, this is not the easiest stuff we've done. It does have to follow a logical pattern. So just make sure that we have that information properly. So in this next one, we have a lot of information. Let's say, we'll make sure we mark it all down. It says AB is parallel to CD, and BC is parallel to AD, and BD is perpendicular to AC. So this one, they gave me opposite sides parallel, and the diagonals are perpendicular. So the first set of information, all this, that's opposite sides parallel. That's enough for a parallelogram. And the next one is, if they're perpendicular, that's enough for the rhombus. So this is just like the one before, but since that parallelogram information is in there, we can classify this as a rhombus. Now we get a lot of things congruent. BE is congruent to ED, so BE congruent to ED. CE is congruent to EA. There is a period here that is, that's not a typo. It's just to represent that there's a break and that this congruency is different. So CE is congruent to EA. And BD is congruent to AC. So that one's harder to mark, but BD congruent to AC. So that tells me that, well, diagonals are bisecting each other. That's the first set of information. Diagonals bisecting each other is a property of the parallelogram. So this is at least a parallelogram. And then that last statement right here, BD being congruent to AC, that's a property of a rectangle. So it's a parallelogram classified as a rectangle. So our closest classification is a rectangle. Don't think we can classify it as a rhombus. Not enough information. Oops. All right, BD is congruent to CA, and BD is perpendicular to AC. So BD, that's a diagonal, right? So the two diagonals are congruent, which is good for a parallelogram, but doesn't appear to be enough. And it says BD is perpendicular to AC. So the diagonals are congruent to each other, and these are right angles. Is this enough to say that it's anything? So again, the first thing I'm thinking is it looks like it's got a property of a rhombus. It looks like it has a property of rectangle, but I'm struggling to find a property of the parallelogram. I don't see opposite sides congruent or parallel or anything like that. And if it fails to meet that first condition, even with this really good information, I can't classify this as anything because that parallelogram information is just not there. So therefore, I'm inclined to go with NA for this one because it's not a parallelogram. BE is congruent to ED. CE is congruent to AE. That is just diagonals bisect each other. That's it. So if diagonals bisect each other, it's a parallelogram. Few more. Angle BAD is congruent to DCB, and ABC is congruent to CDA. So the markings I'm making there, and notice I'm not using right angles because, again, I don't want to assume that this is always a square, but that is just the phrase opposite angles congruent. So the best classification is parallelogram. AB is congruent to CD. AB is parallel to CD. So based on what I've marked and this statement right here, that's enough for a parallelogram. Just like we saw in number, it's the same thing as up here. So we know it's at least a parallelogram, but then they give you that ADC is a right angle. Now, this tells me that this is a rectangle. Even though there's only one right angle in the parallelogram, that is something that we have talked about. That if a parallelogram contains one right angle, the other three must also be right angles. So this is a rectangle. Three more. BE is congruent to ED, which is congruent to CE, which is congruent to EA, with AB congruent to AD. So, first thing I'm trying to look at is there enough information to say it's a parallelogram? And there is. The diagonals are bisecting each other. So this is at least a parallelogram because these diagonals are bisecting each other and they're congruent to each other because all four of them are congruent. That's enough information for the rectangle. But then they gave you these sides right here. Two adjacent sides are congruent, which means, and we just said it's parallelogram, so all the sides end up being congruent to each other. So we have a rhombus, we have a rectangle, we have a parallelogram. That is a square. When you meet the conditions for all three things simultaneously, you will have a square. BD is congruent to CA, so we have diagonals congruent. So that's jumping to the the rectangle property, but then it says BD is perpendicular to AC. So we've actually seen exactly this before. We saw that right here. So we know that those two by themselves are nothing, but then they give you the fact that diagonals bisect each other. There's that parallelogram piece we've needed from that previous one. So now you again have property of parallelogram from the diagonals bisecting each other, congruent diagonals, perpendicular diagonals. This is another way of saying it's a square. And then the very last one I think is actually one of the easiest ones. ADC is a right angle. That's it. That's all they give me. That's nothing. That's not enough information to tell me that's a parallelogram. Right angles really have nothing to do with parallelograms, and if that's the only piece of information, that's what it could be. So, how do we feel with that? I know that's a little bit different. I said I would go over this one. What I'll do, this is the one I had you do in class. I will put up a solution to it so you can see and look for yourself, because we are at 11:38. We are just coming up on the end. So I will put that solution up so you can view it for yourself. And I'll just make sure that this solution right here is this the same way I would have done it. I don't like how this answer key does phrase some things. I don't like it. I don't like using definition of a rectangle. You would use what we have written. Opposite, in a rectangle, opposite sides are congruent. A and D are right angles. That's fine. Right angle theorem. We write all right angles are congruent. So make sure that you have kind of those things written down. But this definitely needed to prove that the two triangles were congruent to each other using CPCTC, and then explaining why it was isosceles, because you have two angles in a triangle which were congruent to each other.